Welcome. I'm Bruce German, professor at the University of California, Davis, and scientific advisor to the Periodic Table of Foods Initiative, the PTFI. And I'm delighted to share this time with you and to provide some insights into where science and innovations are moving in food, what has led to our current challenges, and how the arrival of Foodomics will transform not only the science of how food works, but to translate that science into solutions that can benefit people and the planet. As you've seen throughout this course, our current food system is damaging the planet and our health. We must reimagine food. We're using data and evidence to make food as a system both healthier and more sustainable. We will change how we conduct science with new tools and technologies and know food in new ways. We will combine these tools with local and traditional knowledge from around the world. Understanding how communities have built sustainable food systems for millennia is going to be a key. How do we go from the daunting problems we're faced to effective solutions for food? Well, first, how did we get here? Technologies of today are based on the science of previous eras. The 19th century was defined by physics. Scientists learned about energy, power, the transformation of energy, and engineers took that knowledge and put it at our fingertips for warmth, for light, transportation, and communication. The 20th century was defined by chemistry. Scientists transformed chemicals and affected everything around us, from our houses, our clothing, and our health. We, for example, know all the essential nutrients. Every amino acid, fatty acid, vitamin, and mineral that humans need to eat to survive is mature scientific knowledge. That is a magnificent success story by any criteria. However, an unanticipated legacy of that knowledge and its discovery was the reductionist concept. That is, isolate, purify, make things as simple as possible, identify the one component, the one molecule, the one atom responsible for a particular function. The benefit, of course, was identifying all the essential nutrients and virtually eliminating diseases caused by essential nutrient deficiency. But the world assumed that we were done with food, and the rest of food didn't matter. Oops. The truth is, essential nutrients are a tiny percentage of the components of food, and everything in food matters. To solve the environmental, diet, and health issues of today, reductionism does not, in fact, it cannot work alone. The science of food, agriculture, diet, and health must embrace integrative thinking. A food systems approach is needed. More than one molecule matters. Each molecule interacts with other molecules in foods and within us. Even the context in which we consume the various molecules of food matters. Food is life. To appreciate the complexity of food, we need to know biology itself. The 21st century will be all about biology, using systems approaches to put food into ecological, cultural, economic, health, and governance context. At the center of biology is food. Every organism needs to be nourished to survive. But food is so much more than just nutrients. Food fuels us. It builds and rebuilds us every day. It educates us, it protects us, it can damage us, and it can delight us. Food is complex, and as you've learned in this course, what is in our food is far more expansive than a simple nutritional label would lead you to believe. The diverse food components, proteins, lipids, carbohydrates, metabolites, minerals, all work from complex and integrative biological systems. The quality of food depends on this complexity. Integrative knowledge, both of food's composition and the context in which it's produced, processed, accessed, and consumed, holds the key to food that supports the well-being of people and the planet. Foodomics data matched to food systems metadata will help us define food quality across nutritional, ecological, and social dimensions. We can now build the knowledge for a paradigm shift where all the details of food quality are used for decision-making. The goal is clear. All people everywhere have access to nutritious, sustainable, and delicious food. Let me focus your thinking around new themes in this digital era of big data. The first is pattern. In biology, life is complex, but not random. It is defined by patterns, and we now have the mathematical tools to recognize complex patterns. The same AI tools that are revealing the patterns to recognize faces and voices and traffic can now be applied to food. Databases of the composition of foods from around the world are expanding exponentially. We now need to solve for the patterns of food for people and the planet. Today, every protein, every lipid, carbohydrate, mineral, and small molecule is being assembled into comprehensive databases of the planet's food. Now we must combine metadata that put these components into context. The combined data, what food is and what food does, will propel the knowledge to inform policies, practices, consumer behaviors. This is no small task, but we do have some lessons to guide us. The next concept is diversity, and I mean diversity. Diversity from molecules to ecosystems, from species to scientific disciplines. Diversity is biology's secret to success, and embracing diversity makes it one of our greatest assets in solving the complex challenges of our time. In prior scientific eras, the enabling principle that made physics and chemistry so successful was reductionism. Make things simple. One fuel, petroleum. One fertilizer, ammonia. However, biology is not well understood by making things so simple. We must embrace the diversity that is biology in action. Different plants have different compositions. The same plant has different compositions depending on its environment. And of course, people differ from each other, and we change as we age. We need to understand our food and its complexity, and ourselves and our diversity. That means we have to measure. Only by measuring our food with sufficient accuracy can the diversity of biology be an asset to the health of humans and the planet. You've seen examples of what omics can do. Now I want you to imagine. Imagine that you could measure all proteins, all carbohydrates, all lipids and minerals and metabolites, all components of foods simultaneously. You have to imagine it because it's not possible today. But with the arrival of the PTFI, we have the capabilities to measure all the components of food simultaneously. Now imagine, what are all the changes in food depending on the seeds you plant? What are all the changes in food depending on the soils you grow them in? What are all the changes of every single component in response to every single processing step in food? And of course, what are all the changes in us in response to consuming different foods. How do these food combinations interact in complex diets? That's the goal. Scientific diversity is also critical in the ways we discover and research food. The discoveries that the world needs to revolutionize food will require scientific diversity of minds and imaginations. You can learn from different disciplines, from different parts of the world, from different methods, perspectives, and different biological resources. Finally, I want to talk to you about joy, the sheer exuberance of performance. What ill health robs you of first is your capacity for joy. Food systems are destroying our planet. Poor diets are destroying our health and robbing us of joy. As you build food knowledge, you'll come to understand the true breadth of food quality, how foods can not only be safe, but make people who consume them safer. How foods can be combined to provide diets that make each of us healthy in the way we aspire for our own health. How food can actually heal our planet. How food systems can be developed to manage food supply and minimize waste and distribute wealth fairly. And how we experience foods and how they delight us, along with everything else that you must deliver for the world, regenerating the land, air, and water, restoring health and the freedom from diet-dependent diseases, delivering equity and diversity so wealth is distributed across the food system. Along with all of those, you'll deliver joy. As Maya has stated in her lesson, we need to ensure that innovation leads to inclusion, not exclusion. It won't be easy, but it's worth it. Imagine the joy of a better future, where everyone has enough to eat, where food is safe, nutritious, and culturally appropriate, where farmers can grow food in ways that nourish local ecosystems and address diet-related diseases in their communities. The joy of utilizing the power of food for human and well-being is upon us. This is the goal. The discoveries that you make will bring joy to people around the world. Making those discoveries will bring joy to you personally. I can't wait to share in the joy of the discoveries you're going to make. Let's go make them.